Hello, welcome to Algebra 1, lesson 3.1. So in the module system on the computer, it calls it 2B, but it is the third module. So this is Unit 3, Lesson 1, which is going to be about vocabulary. And so our vocabulary for this unit we're going to start off with is linear systems. Now the entire unit is about linear systems. A linear system is when you have two or more linear equations that work together, and how those lines interact helps us find the information we need to answer our real world problems. Usually when you have two lines, you find where they intersect, and that would be the solution that you're looking for. But when you use it for real world information, we did it actually a little bit in the last unit when we compared cell phone plans. Which one is a better plan if you used it in certain ways, like if you used more data or if you used less data. And so this is what linear systems do, help us to interpret the data that we have in order to make decisions. So a linear function is a function with a constant rate of change, and it's a straight line graph. Remember, we had different kinds of straight line graphs. There's the one that if this has a slope of 1, 1 every time, right? So the slope m equals 1, that is y equals x. Remember, if you have, that's supposed to be a horizontal line, you have y equals a number, that slope is 0. And if you have x equals a number, you have a vertical line and there is no slope, okay? Those are three particular types of linear functions. This one is not a function, but the other two are. These are three different kinds of linear equations that you should be familiar with. But a line can be anything. This is a positive slope. A line going in this direction would be a negative slope. Up a mountain, positive, down a mountain, negative. So linear functions represent real-world phenomena. That's a linear model. Again, it goes back to the cell phone comparison equations that we had in the last unit that we looked at. Ordered pair. An ordered pair is right here. It's going to be in parentheses. It's going to be on a coordinate plane. If you have a coordinate plane and you have a point on that coordinate plane, it is associated with a linear pair. This point, the x represents the horizontal movement from the point of origin. Point of origin is where the y-axis and the x-axis intersect. This is the point of origin. Its ordered pair is 0, 0. So a point on this coordinate plane would be in the format where x is movement on the x-axis, or the horizontal change, and y is the movement on the y-axis, or the vertical change. So this point would be 2 in the positive, to the right is positive, to the left would be negative, and then up 1. So this point is 2, 1. This point has a horizontal movement in the negative direction, so negative 3, and then 2 in the vertical, which is positive. Down here would be the negative. Okay, negative 4. So this is an ordered pair when it's written like that. Many times we see answers in ordered pair form, such as the x and the y intercepts. Slope. Remember, the slope is how quickly a line rises or falls. So you can see a couple of different slopes here, right? And a horizontal slope would be 0, and a vertical slope, there is no slope. All of these are I'm trying to get them to originate from the same point. And you can see different types of slopes. But it's the ratio of the vertical change to the horizontal change. So you take the change in y and you divide it by the change in x, right? So if you have a line, and it goes through 2 points. And 1 point is 4, 4, and the other point is 1, 2. It's the change in y over the change in x, so you're going to call 1.1 and the other 1.2. Oops, that's supposed to be a 2, not a 3. There you go. And so then you have to create the change in y. So you're going to put the y's on top. So I'm going to put 4 on top and my x for 4 on the bottom. Then change means we're going to find the difference in something. So we're going to subtract. I already used 0.1, so now I'm going to use 0.2. I'm going to put the y on top and the x on the bottom. So 4 minus 2 is 2. 4 minus 1 is 3. So slope is usually indicated with an m. So m in this case is 2/3, or slope is 2 over 3, also sometimes called rise over run, because the top number is the vertical change, so it's how far it'll rise, and the bottom number is the horizontal change, so how far it will run. If you have negatives, they go the opposite direction. A negative on the top would go down, and a negative on the bottom would go to the left. Usually you'll just have one negative just on the top if you have a negative. So our next, and most of these vocabulary terms are review for you because I know we went over them just even in the last unit. Because we're using linear functions, we have a lot of the same vocabulary. All right, so substitution, that's when we're replacing one value for another. When you have something like 2 plus x equals y, you can say solve for this equation when x equals 1. And then you substitute 1 where the x is. So you'd say 2 plus 1 equals y. So 2 plus 1 equals 3. So y equals 3. Okay, so substitution is like when you're playing a sport and somebody gets injured, you send in a different player. You don't continue playing the game with it empty. You send in a different player to that position. X-intercept, that goes back to our graph. We have our y-axis and our x-axis. And the x-intercept is where the line, or the graph of the line, would cross the x-axis, okay? And that brings us to y-intercept, which is exactly the same thing, but on the y-axis. It's where the graph of the line would cross the y-axis. Axes. All right, so here's an example of a linear system. This graph shouldn't be shown yet, but it's a race. You versus a rider on a horse. And you're going to run at a rate of 0.2 kilometers per minute. The horse runs at a rate of 0.5 kilometers per minute, but needs to have a saddle put on first. It takes 6 minutes for the horse to be saddled. How far can you get before the rider and the horse catch you? So this is you in the blue line. You're running at a rate of 0.2 kilometers per minute. So 0.2 times time. The horse runs a distance of 0.5 kilometers times t minus 6. Well, where did we get that minus 6 from? If you notice, he started at the 6. Well, that's because it takes 6 minutes to get the horse saddled before he can even get started. So it seems as if you got a head start here, but you still got caught right here where the lines intersect. And then, oops, let me move this out of the way. You got caught at 10 minutes and you only got 2 kilometers away. And it says, run faster next time. All right, so some questions that will be answered in this unit, in this module. How do I compare two linear functions given different representations? How do I solve a system of linear equations graphically? It's like our example we just looked at. How do I solve a system of equations using substitution? That's one of our vocabulary words, isn't it? How do I prove that a system of two equations in two variables can be solved by multiplying and adding to produce a system with the same solutions? How do I interpret the solution of a system of equations within the context of my problem? So this gets into some of those real life examples that we're talking about. So those are the things we're going to go over in this unit in the following lesson. So I'll see you then.